Okay, so the first section is section 1.4. It's going to be solving quadratic equations. So is what we're going to do. We're going to take a quadratic equation, ax squared plus bx plus c equal to 0. And so when you're solving a quadratic, having it equal to 0 is a key piece of the puzzle. If you get it equal to 0, that opens up the option to use that factoring that we did in the labs there. So we can use factoring and we can use quadratic formula. We'll go over both of those in this lesson. So factoring and quadratic formula are the methods that we're going to focus on in this section. So, but to do either of those, you need to get the equation equal to 0 first. Okay, so get the equation equal to 0 first. You do that, then things are going to go in your favor. Okay, so, but solving quadratics by factoring, when they will factor, is really an easy thing. So let's start with solve by factoring. So when you're solving by factoring, what's going to happen is you're going to end up with two factors. And so I'm kind of starting at the factored forms spot here. So let's say we had already factored one, and we got the factors x plus 7 and x minus 5 are our two factors. Okay, since it's equal to 0, there's this thing called the zero product property that tells us that if two things multiply together and equal 0, then at least one of them is 0. But because both of these have a variable in it, then it's possible that both of them are 0, because 0 times 0 is also 0, right? So what you do, once you get it factored, you take each individual factor, x plus 7, set it equal to 0. And you take the other factor, x minus 5, set it equal to 0. And you're going to solve each one of those individually. So I'm going to subtract 7, and there's x equals negative 7. I'm going to add 5. It's going to be x equals 5. I'm going to get two answers for these quadratic equations. I got a negative 7 as an answer, and then I got a positive 5 as an answer. If I plug one of those back into the for x, let's say I plug in the negative 7. Negative 7 plus 7 is 0, and then negative 7 minus 5 is negative 12. 0 times negative 12 is still 0, so that one works. If I plug in the positive 5, 5 plus 7 is 12, but over here 5 minus 5 is 0. 12 times 0 is still 0. So both of these are answers here. So we get the factored form, and then we just set each factor equal to 0 and solve it. Okay? The biggest thing here is being able to get to this factored form. We got to be able to do that. Okay? So let's get an example where it's not factored for us yet. But it's already equal to 0. So we'll start out, kind of stepping our way into these things. So in this one, we've got x squared plus 7x plus 12. It is equal to 0. So it is ready to do some factoring with. So we're going to do the rules of factoring. We're going to first look for a greatest common factor. So x squared plus 7x plus 12. There's nothing in common between all three of them. So there's not a GCF. Then I look at how many terms are there on that side. Well, 1, 2, 3 terms. So that's an X method thing. Okay, so I'm going to go and I'm going to do my X method. So I'm multiplying to be 12, adding to be 7. What two numbers multiply to be 12 and add to be 7? 4 times 3. Because there's a 1 in front of my x squared, I can go straight to my factors. X plus 4, x plus 3. Okay. There's the factored form. So now that looks like example A did. And now I take each of those factors X plus 4 equals 0. X plus 3 equals 0. And I get x by itself. X is negative 4. X equals negative 3. If I take one of those answers and plug it back in the original problem, negative 4 squared is 16, plus 7 times negative 4 would be negative 28. So 16 plus negative 28 is negative 12. Negative 12 plus 12 is 0. So that checks. If I plug in the negative 3, same thing's going to happen here. I'm going to have positive 9 minus 21, which is negative 12, plus 12 is 0. Both of those work in the original. Okay? So we get the factors, and then we set the factors equal to 0. That's the key to doing these. Okay? Let's go to one that isn't equal to 0 yet. Let's step it up a little bit at a time. 6x squared plus 7x minus 2 is equal to positive 1. Not too crazy here, nothing is huge here, but a little bit more difficult problem. Okay, so first thing, if we're going to solve that by factoring, I have to have it equal to 0. So I need to get rid of this 1 that's on the right-hand side. So it's a positive 1. To move it to the other side, I'm going to use a minus 1. So I'm going to subtract it to its like term over there. Now I have 6x squared plus 7x minus 3 is now equal to 0. So now I've got it equal to 0, and I'm ready to do some factoring. So again, I'm going to go through the rules of factoring. Number one rule is GCF. So 6 and 3 have something in common, but the 7 messes it up. So no GCF. But then I look to how many terms do I have? I have 1, 2, 3. I have 6x squared, the negative 7x, or the positive 7x, and the negative 3. That's 3 terms. So this is an x method, but this one has a number in front of the x squared. So we've got to go through the grouping stuff for this. So it's a good one to practice on. So on the top of the x, we got to multiply 6 times negative 3. This is the step that most people forget to do on a problem that has a number in front of the x squared. 6 times negative 3 is going to be negative 18. That's what's going to be in the top of my x. The 7 is going to be in the bottom. That doesn't change. Whatever's in the middle is always in the bottom. Now I'm looking for two numbers that multiply to be a negative 18 and add to be a positive 7. 9 and negative 2. Very good. Now, the difference in this one and the previous problem is the fact that there's a number in front of that x squared. So I can't go straight to my factors. My factors are not x plus 9 and x minus 2. I have to go in and I have to do this grouping step. So I'm going to rewrite the problem like this. And I'm going to group the first two together and then the second two together. This is directly what we had done in the lab there. But instead of, it didn't give it to me, I had to put it in there from my x. I only have to do that if there's a number in front of the x squared. This is the only time I have to do this. Now, what's the GCF of 6x squared and 9x? 3x. So I'm going to pull a 3x out of the front of that. What's that going to leave in the parentheses? 2x plus 3. Very good. And now what do I need to pull out of the second pair to leave a 2x plus 3 in the parentheses? Negative 1. We've seen that a lot tonight. And now my factors are the 2x plus 3 and the 3x minus 1. Okay. So now I have the factored form. It's a more difficult one to factor because it had that number in the front. But I'm going to take each of those factors and set them equal to 0. 2x plus 3 equals 0. 3x minus 1 equals 0. And I should get fractions when I get done here with the answers. I'm going to subtract 3. 2x is equal to negative 3. And then the last step, I would divide by 2. And that's negative 3 over 2. The other one, I'm going to add 1 and then divide by 3. I have 1/3. So those are my two answers for solving that by factoring. A little bit more difficult because we have a number in front of the x squared. So it's a little bit more lengthy factoring step there, a little bit more work to do on the solving, but it's the same kind of setup. Let's try another one of those. Let's say we had I'm going to have to kind of, I'm making one up off the top of my head here. So let's do a negative 8 over there. Let's do that. I think that'll work out nicely, I believe. 3x squared plus 13x plus 2 is equal to negative 8. We got one that again has a number in front of the x squared and it is not equal to 0 yet. So the first step is to get it equal to 0. So what do you do to get it equal to 0? Add 8. So move this 8 over there with its like term. And it's in descending order, x squared, 13x plus 10 is equal to 0.
If it wasn't in descending order, would you put it in descending order?
Yes, absolutely. I would go ahead. Yeah, right when I looked at the problem, the first thing I would do is rewrite it in descending order before I started doing anything. That will make your life a lot easier if you'll do that. Okay. And now we can start our factoring. Is there a GCF? 3, 13, and 10. I don't see anything goes into all of those. So I'm ready for my X. What goes on the top of my X? 30. 3 times 10 is 30. 13 goes on the bottom. What two numbers do that? 10 and 3. It doesn't matter what order you put the 10 and 3 in there in the middle. I'm going to put it in what I think is a logical order, which would be putting the 3x with the 3, x squared, and the 10x with the 10. To me, that makes more sense to do it in that order than it would to put the 10 first, because it makes the GCF so much easier. So then I'm going to group the first two together and the last two together and get their GCFs. So what's the GCF of 3x squared plus 3x? 3 and x, leaving x plus 1. And then what's the other one? What do I pull out of that one? No. A plus 10. They both have 10 in common. Then that's going to leave me an x plus 1 in there. Then my factors, my factored form, that's what I'm looking for here. I've got the x plus 1, then I've got the 3x plus 10. Now, what am I going to do with those two factors? That's right. Set them both equal to 0. So x plus 1 equals 0. 3x plus 10 equals 0. And we're just going to get x by itself on all of those. So I'm going to subtract 1. So one of my answers is -1. The other answer is a fraction, -10/3 or 10/3. And you can check those in the original, and they both work. That's the correct answers there. But the factoring is the key. Get it equal to 0, make sure it's in descending order, and then it's X method stuff when it's a trinomial like that. They don't get too out of hand as far as the big numbers or anything like that with this stuff. It's going to be, doable numbers. That's when it says solve by factoring. Let's try this one. To me, this is an easier problem, but it always seems to give students a little bit of a hiccup here on this because it doesn't have 3 terms in it. And we kind of lose our mind a little bit when everything isn't the same all the time. So if we're going to solve it by factoring, what's the first thing that I have to do? Get it equal to 0. So I'm going to either move the 7x squared or the 8x. It doesn't matter which one. What I suggest is that you try to make sure that your squared variable is positive. And since the 7x squared is already positive, I'm just going to leave it where it's at, and I'm going to move the 8x. So how do I move that 8x? Yeah, I'm going to plus 8x. And those are not like terms. So that's going to end up being this 7x squared plus 8x is equal to 0. It's not a trinomial. It's only 2 terms. So we still follow our rules of factoring. So the number 1 rule of factoring is to look for what? Greatest common factor. What greatest common factor do these two have? X. Both of them have an X in common, so we're going to factor out the X, and that's going to leave 7x plus 8 in the parentheses. So that's my factored form. I didn't have to do the X method here because I didn't have 3 terms. So that's the difference here. Now I've still got 2 factors. I've got the X that's a factor, and then I got this 7x plus 8 that's a factor. So I'm going to take each of those factors and set them equal to 0. On the first one, x equals, there's nothing to do to get x by itself. It's already by itself. So that one's done. I've got x equals 0. That's one of my answers. The second one I got to do a little bit of work on. So I'm going to move the 8 and then divide by the 7. And there's my -8/7 is my second answer. So I still got 2 answers. I got x equals 0 and I got x equals -8/7 on that one. So a little bit of work, but nothing just terribly strenuous about that. But the key is noticing, hey, once I get it equal to 0, I still follow those rules. Get the greatest common factor out first, if there is one, and then factor any other way you can. Let's do this one. Let's say we had 6x squared plus 5x is equal to 2x. So again, we're trying to solve by factoring. That's our goal right now, is to solve by factoring. So to solve by factoring, the first thing that I need to do is get the problem equal to what? 0. That's the first step. So the easy way here would be move the 2x, because that's just one thing to move. So I'm going to subtract it to both sides because it was a positive 2x, so I'm subtracting 2x to cancel that out. and move it over to the other side, and that's going to give me 6x squared plus 3x is now equal to 0, which is what I wanted. I wanted it equal to 0. Didn't really care what happened other than that. Then, what am I doing? Greatest common factor. Always look for that first. Before you do anything else, look after you get it equal to 0, GCF, which would be 3x. And that's going to leave what in those parentheses? 2x plus 1. Okay, so now we got two factors there. We got a 3x and we got a 2x plus 1. Set them both equal to 0. A little bit more work on this one to do. Divide by 3. 0 divided by anything is 0. So that's x equals 0. This one I'm going to subtract 1. And then divide by 2. Negative 1/2. So solving by factoring there with GCF. We've done X method, we've done GCF, and then setting those factors equal to 0. That's the keys. Questions about those 6 that we've done there? Okay. Let's look at this one. What are we on? G. Let's say we had x squared minus 25 equals 0. So we've got a quadratic here. It's got x squared in it. That's what makes it quadratic. And it's equal to 0. So it's ready to solve by factoring, hopefully. But it only has 2 terms in it. Is there a GCF between these 2 terms? No. So it's a little bit different than the last ones. That 25 doesn't have an X on it like the last couple of them had. So when I look at that and I see a minus sign in the middle and 2 terms on something that's got an x squared in it, I think about differences of squares. So I'm thinking what squared minus what squared. So what squared is going to get me x squared? X. What squared is going to get me 25? 5. Now, because I can rewrite it like that, that's a difference of squares. So my factors, one's x plus 5, the other one's x minus 5. And then now I've got it in factored form, which is where I was before. All I got to do now is set each factor equal to 0 and get x by itself. And I get positive 5 and negative 5 as my 2 answer choices there. So factoring as a difference of squares is a possibility for solving by factoring. Here's just a new one. 4x squared minus 42 is equal to 7. Yeah, get it equal to 0. That's kind of the idea of what we're going to try to solve by factoring. So get rid of that 7. So that's going to be 4x squared minus 49 is equal to 0. And then I've got it equal to 0, so that's where my factoring rules start applying. So is there a GCF between 4x squared and 49? No. But it's two terms with a minus sign in the middle. And what do we know about 4 and 49? They're squares, yeah. What squared is 4x squared? 2x. What squared is the 49? Ooh, that's nice. So that allows me to factor it as a difference of squares. So I've got the 2x plus 7 and the 2x minus 7. Doesn't matter what order. If you put the 2x minus 7 first, that's fine. It doesn't matter. Okay? But just rewriting it as a difference of squares lets us use our factoring to get our answer. So we're going to get two answers here because we got two factors. So we're setting 2x plus 7 equal to 0, 2x minus 7 equal to 0, and getting x by itself. So one of the answers is negative 7 over 2. And the other answer is positive 7 over 2. Got to notice over here on the other one that was a difference of squares, we had a positive 5 and a negative 5. Over here, it's a difference of squares. We have a positive 7 over 2. We have a negative 7 over 2. Anytime it's a difference of squares, you're going to have the same number, but one's going to be positive, one's going to be negative. That's how your solutions are going to go out of that. So differences of squares, always a nice way to factor and solve out of that. So that leads us into the next method of solving that I didn't list at the front, but because you could do this by factoring. I want us to talk about it just a little bit because I think it can make things easier sometimes. And that's solving by square roots. So this is another method that can be a shortcut sometimes out of that. Solving by square roots, that's legal when there is no BX term. Okay. If there's not a term that has the plain x in it, which those last few problems that we've done there, the difference of squares problems, they didn't have a plain x in them. They had x squared, but they didn't have plain x in them. The square roots can be used to solve. So let's look at an example of that. So let's do, what letter are we on here? I. Example I. And let's say we had x squared minus 9 equals 0. So we're not going to factor this one. We're going to solve it by square roots, which is a little different than factoring, okay? And it only works if you don't have the BX term. So in this problem, there isn't a plain x in it. It's got a x squared and a plain number. What I can do is move that 9 over there to the other side. And I get x squared is equal to 9. And what I'm then allowed to do is undo the squaring of x. So what's the opposite of squaring something? It's taking a square root. Okay, the square root, and on the number side, I'm going to do a plus or minus, because when you square something, if you square a positive 3, you get 9. But if you square a negative 3, you also get 9. So you have to have that plus or minus in front of it. On the left side, the square root of x squared is just x. On the right-hand side, you get the square root of 9, which is just 3. Yes, you need the plus or minus in front of that, yes. So you got two answers. You got positive 3 and negative 3. That problem could also have been done by factoring with differences of squares, but I think this is a little bit shorter out of that. You could have factored it as x plus 3 and x minus 3 and set those factors equal to 0. but the square roots is a little bit faster. Let's look at another one. Let's say you had something like 9x squared is equal to 25. Maybe it's not even equal to 0. But when I look at that problem, I see that it doesn't have a plain x squared in it. It's got, or doesn't have a plain x in it. It only has x squared in it and numbers. So what I want to do is get the x squared by itself. So how do I get x squared by itself? Divide by 9. And I'm going to leave that as a fraction. Now I have an x squared equal to a number. And I'm going to take the square roots to get rid of the squared on the x. Plus or minus on the number side. On the square root of that fraction, all you got to do is take the square root of the top. What's the square root of 25? What's the square root of 9? Boom. You have positive 5 over 3 and negative 5 over 3 are your two answers for that. That's much faster than the factoring is. It only works, though, if you don't have the plain x. Now, Anna. Like two separate ones? Yeah, that's fine. Yeah, that's fine. I'm just saving writing by writing the plus or minus in front of it. If you wanted to write x equals 5 over 3 and then x equals negative 5 over 3, that's the same thing. That's saying the same thing. Yeah. I just do that plus or minus just to save a little bit of time. Okay? All right. Now, where it gets a little bit more interesting is when that isn't a perfect square over there. And this is where it comes back to that stuff we did a couple of weeks ago when we were simplifying the square roots. So, example K, let's say we had something like this. X squared is equal to 18. Okay. So this looks a lot like the previous example, except for that number isn't a perfect square. I can still take the square roots because it doesn't have the plain x in the problem. I've got x squared by itself. I can go ahead and say x, the square root of x squared is x. And then I'm going to need to simplify the square root of 18. So that's where we did the factor tree thing a couple of weeks ago. It's been a minute. So we need two numbers that multiply to be 18. 9 times 2, and then 9 breaks down to 3 and 3. We're taking a square root, so there's a pair of 3s. So that's going to be 3 radical 2. And that's simplifying a square root. If you were out a couple of weeks ago, you definitely need to go back and watch the videos from that, because that's going to come back and get you a lot tonight. That is an important thing, simplifying square roots. Not getting decimal answers, getting simplified square root answers. Let's try this one. Let's say we had 5x squared equals let's do something nice. 60. That's a good one. So very similar to example K, except for it's got a number in front of the x squared. So what do I do first? Yeah, get rid of that 5. It's going to leave me x squared is equal to 12. 60 divided by 5 is 12. And then I have the x squared by itself, so I can take the square root. Plus or minus on the number side. I'm going to do the factor tree for 12. Whether you do 6 and 2 or 4 and 3, it doesn't matter. Because you're going to break those numbers down, and we're looking for a pair. So there's a pair of 2s. So that's going to be 2 radical 3. Goes on the outside. Yeah, whatever number's in the pair, that goes to the front, and then the one that doesn't have a buddy stays inside. That's the way I always think about that. All right. Let's do another one with square roots. Let's say we had 3x squared plus 4 is equal to 2x squared. So if I'm going to solve this by square roots, I need to get the x squareds on one side, the numbers on the other, right? So what do I want to do here? Give me a step. Okay, if we do that, that's not wrong. That's going to give me x squared plus 4 equals 0. Okay, then move the 4. 2 steps to get there, no problem. So we have x squared is equal to negative 4. And then, so we have the x squared by itself now. That allows me to then take the square roots. Plus or minus on the number side. We've got a square root of a negative number. This goes back to 2 weeks ago again. What's the square root of 4? 2. Because it's negative, this is going to be 2i. That's the complex numbers coming up. If there's a negative under the square root, that's where that I comes from. Complex number system. We took the square root of 4 like we normally do, but then because it was negative, that's where the I came from. Let's say we had negative 3x squared minus 6 is equal to 18. So a similar problem, just a little bit different. What's a good first step here? Yeah, move that 6 by addition. Yeah, that's a good way. That's going to give me negative 3x squared. It's now equal to 24. Divide by that negative 3. That's going to get our x squared by itself. That's going to be a negative 8 over there. And then because I have the x squared by itself, I'm now allowed to do the square root. So I need to break down the 8. So I have a pair of 2s, and then a 2 that doesn't have a buddy. So that's going to be a 2 on the outside, a 2 on the inside. What else is on the outside? Why? Because it was a negative 8. So that I comes out there with that 2. plus or minus 2I square root of 2. Simplifying those radicals. It's going to be a thing. Shows up a lot from here on out in 100 and 110. We'll get plenty of practice at it. Hopefully we'll get better at it. So when can you solve by square roots? Yeah, there's no plain x, no bx term in there. That's when you can solve by square roots. If you have an x squared and a bx in there, you've either got to do factoring or quadratic formula. We're about to do quadratic formula next. Okay, so factoring or quadratic formula. If you have a plain x in there, you've got to either do factoring or quadratic formula. Sometimes factoring works. Quadratic formula, the nice thing about it is that it always works. It's one of those universal tools that will work in every problem as long as you plug things in the correct way. So let's get into the quadratic formula, which is the last part of the section 1.4. Okay, so quadratic formula. Remember, a quadratic equation is written ax squared plus bx plus c is equal to 0. To use the quadratic formula, you got to be equal to 0 first. Said that earlier, just doubling down on it. To use the quadratic formula, got to have it equal to 0. It needs to be in descending order, just like if you were going to factor it. Okay, the quadratic formula is as follows. X equals negative b plus or minus radical b squared minus 4ac divided by 2a. If you sing that to the tune of Row, Row, Row Your Boat, you'll have it memorized and you'll be singing it in the shower and stuff. But there's other, you can YouTube sing the quadratic formula, and there's a pair of ladies that do the Adele song "Rolling in the Deep." It's a pretty awesome version of it. But they sing this thing. But just memorizing those pieces. B is the number that's in front of plain x. A is the number in front of x squared. C is the plain number that's hanging down on the end. Okay? So this formula, when we simplify it and work it out, that's going to be our solutions to a quadratic equation using the quadratic formula. Okay? So let's do a few examples of this, and then we'll get into some of the particulars of this. I have no idea what letter we're on because I've added a bunch of... Oh, the donut example. Some patriotic wrinkles on there. Okay. Yeah, there's a nice donut. Y'all that hadn't ate supper yet, you're hungry? I'm right there with you. So let's do x squared minus 4x is equal to negative 2. We won't get too crazy with this first one. So it is a quadratic equation. It has a x squared and a plain x. So right away, I know I can't use square roots. So when I see that, I know, hey, I got to get it equal to 0. No matter what I do after that, I've got to get it equal to 0. So let's move this around to get it equal to 0. So what would be the best thing to do? Add the 2. So that's going to be x squared minus 4x plus 2 is equal to 0. Okay. Now, I would love it if everything would always factor, but it doesn't. Okay? I'd love it if my truck never ran out of gas, but it doesn't. It runs out. Okay? So the reason I need to do quadratic formula on this is because if I try to do my little x method thing, there's nothing that multiplies to be 2 that'll add to be negative 4. So we have to have another method to solve this. So that's where the quadratic formula comes in, because factoring won't work on this one. So what I do, I will make a list of what A, B, and C are. That way I don't screw something up. A is 1, that's the number in front of x squared. B is negative 4, that's the number in front of plain x. And C is positive 2. So that's my A, my B, and my C. And I'm going to use that in the quadratic formula. If you write the quadratic formula down as many times as I do tonight, you'll have it memorized before you leave here. You're not going to have to work at it. X equals negative B plus or minus B squared minus 4AC divided by 2A. Okay. So there's my quadratic formula. Now I'm going to plug in the numbers from my A, B, and C. So the negative B there in the front, negative 4 would be positive 4 plus or minus, then the square root, and I'm going to square negative 4. 4 times A times C, and then all of that is divided by 2 times A. So I've zoom in a little bit there so we can see a little bit better. So I've plugged in the things, the A, B, and the C. Now I'm going to start working out those pieces. I'm going to start inside of the square root because that's where most of the work's going to be. So I'm going to square the 4, the negative 4, so that's going to be 4 plus or minus 16 minus 8. 4 times 1 times 2 would be 8. And then on the bottom, 2 times 1 is 2. Do a better job there. So that's going to give me 4 plus or minus the square root of 8 over 2. This is where I then simplify the square root. So let's do that factor tree thing again. The 8. So 4 times 2, 2 times 2. There's a pair of 2's. So that's going to be 4 plus or minus 2, radical 2. And then here's where I split it into 2 pieces. I put 2 under both of those. That 2 that's under both of those is this 2. That's where that's coming from. Okay? So this 2 radical 2 here, that's the radical 8. This 2 underneath here is the 2 under each one of those. That's the common denominator idea. The reason I'm splitting it apart is because now I can simplify 4 over 2, and then this 2 in the front and this 2 in the bottom can simplify one another. Okay? So that's going to give me x equals 2 plus or minus the square root of 2.
So when you divide that 2, it just takes off the 2 in the front.
Yes, it won't touch the 2 inside of the radical, but it can divide into the number that's in front of the radical. It can't touch the number inside of the radical, but it can touch the number on the outside. That radical kind of blocks it off. All right. Let's do another one. See if we can get a little bit better, get more comfortable with it, because that's the key, is getting comfortable with this. So example P, let's say we had x squared minus 3x plus 5 is equal to 15. Say again. Subtract 15. Get it equal to 0 first. So it doesn't matter if I'm factoring or quadratic formula using the quadratic formula. Let's say it that way. It doesn't matter. I got to get it equal to 0. So because it has the x squared and the plain x. So I have, make sure I got my numbers right. Yeah. So now I have x squared minus 3x minus 10 is equal to 0. This one would actually factor, but I'm going to show you doing it with quadratic formula, because quadratic formula, the beautiful thing about it is it always works. If factoring does not working for you, you can't find the numbers, you can still do quadratic formula and get the answers. It will always work. It's the universal tool. It's the hammer in the toolbox. It can tighten things up and it can loosen things up. Okay, so quadratic formula really does a lot. So A is 1, B is -3, and C is -10. Those are my A, B, and C. And I'm writing my quadratic formula again. X equals -b plus or minus radical b squared minus 4ac divided by 2a. If you like Gilligan's Island, there's a Gilligan's Island theme to it. Plugging in the stuff. Okay. 3 plus or minus the square root, -3 squared, 4 times a times c, divided by 2 times a. So -b, so -3, that's why it's that +3 in the front. Then I've got b squared, so that's -3 squared, minus 4 times a times c, all divided by 2a. So I'm simplifying that. Going inside of that square root. That's going to be 9 plus 40. And then it's got a 2 on the bottom. Now, at this step, once I get the underneath the square root stuff done, I'm looking to simplify that. Do we know the square root of 49? Ooh, that's nice. So that turns into 3 plus 7 and 3 minus 7 all divided by 2. So I'm going to split it apart and do 3 plus 7. I'm going to do 3 minus 7. Because those are regular numbers now. I don't have a radical in there anymore. Because the square root of 49 was just a regular 7. So that allowed me to split it apart. Because now I can do 3 plus 7 and get 10 and then divide that by 2. And I can do 3 minus 7, get -4, and then divide that by 2. And that's going to give me my two answers. So that's 10 over 2, which is 5. That's -4 over 2, which is -2. It's fine. Absolutely fine. Yeah. The more that you can do kind of in one step, the better. I just kind of trying to write every step so we know where everything comes from in notes. But yeah, by all means, skip what you can skip. Okay. So here, because we didn't have any square roots left, and it's nice plain numbers like that, what that tells me is that problem would have factored. But we could still get the answers of the quadratic formula, whether it factors or not. Okay. Let's do one more. Example Q. 2x squared minus x plus 3 equals -1. This is the longest lesson of the night. The other two are really short. Promise. This is the longest lesson. It's the one that's got all the stuff in it. We always have one that's kind of heavier than the others, and the rest of them are pretty easy. This one is the heavy one. So, first step. Add 1. Get rid of that 1. So there's my 2x squared minus x plus 4 is now equal to 0. So I've got a quadratic. It's equal to 0. If I was thinking about factoring, 2 times 4 is 8. There's nothing that multiplies to be 8 and adds to be -1. So that tells me I have to do quadratic formula on this one. Which remember, quadratic formula, x equals -b plus minus radical b squared minus 4ac divided by 2a. I lost my voice there. Okay, so I'm plugging in A, B, and C. Okay. 1 plus or minus the square root, negative 1 squared, 4 times A times C. We got a 2 times 2 in the bottom this time, so a little bit different because we got a different number in the bottom, but it's all the steps are the same, one piece at a time. Excuse me. So I have 1 plus or minus the square root of 1 minus 32, and all of that is over 4. So that's going to be 1 plus or minus the square root of negative 31 over 4. So what do we know about 31? Is it a perfect square? No. Does it break down? No, it's actually a prime number. But because there's a negative under there, what will come out of the radical? An I. So we have 1 plus or minus I radical 31. And then this is the part where you split it and put the 4 under each of them. I actually think the ones with complex numbers are easier to write the answers to because you don't have to do any, there's not really any simplifying much left to do. You just split it apart and write it like that. That number underneath the square root is a special number. Okay? So that's the last part of this section. That b squared minus 4ac, it has a name. It's called the discriminant. The value of that decides what kind of solutions you have. If the number under the square root, the b squared minus 4ac, if it is greater than 0, what kind of numbers are greater than 0? Positive. You're going to have 2 real solutions. It also means that the graph's going to hit the x-axis in 2 places. If b squared minus 4ac is equal to 0, that's just 0, right? Then you're going to have 1 real solution. The graph hits the x-axis in 1 place. And then the last option is if b squared minus 4ac is less than 0, it's negative. You're going to have 2 complex. Remember, complex is the stuff with the I. And the graph doesn't touch the x-axis at all. So one of the things that you can do to kind of help yourself a little bit with this is if you graph the equation that's equal to 0, you can see where it's hitting the x-axis or if it's hitting the x-axis. So like, for example, if I graphed that problem right there, 2x squared minus x plus 4. I'm going to go to my calculator, 2x squared minus x plus 4. When we solved that with quadratic formula, we had complex solutions. That tells me, and the discriminant was a negative 31. The b squared minus 4ac was negative 31. That tells me that should not touch the x-axis. If I hit graph, see that parabola not touching the x-axis? That tells me I got complex answers. If I graph what's equal to 0 and it doesn't touch the x-axis, I should have complex solutions. If I were to go graph this problem, x squared minus 3x minus 10. So I'm going to do that. X squared minus 3x minus 10. I had two real solutions because the discriminant, when I did it with quadratic formula, was a positive number. Look how many places it's touching the x-axis. Okay. The graph of what's equal to 0 can show you where your answers are. That's kind of a cheat code to this stuff, is that you can find answers by finding where it hits the x-axis. That can help you be able to find right answers. Even when we're struggling with quadratic formula or we're struggling with factoring, we can use graphs to help us find answers. So that's an option out of that, okay? All right, so that is section 1.4. It was a lot of stuff, a lot of examples. The next couple of lessons are not near as long. So let's just trudge through here. And the next lesson is the application of quadratic functions. So it's word problems. That's what it is. Okay. So we're going to write a few word problems here. I don't try to get just crazy difficult with word problems with this. I try to make them, I like the ones that are geometry related because you can draw a picture for them really well. That's the kind I like. That's the kind I like to put on quizzes and tests. Okay. So let's start with this problem here. Example A for this one. A rectangular poster has an area of 216 square inches. The width is 6 less than the length. Find the dimensions of the poster. So get a word problem here. It says a rectangular poster. So the first thing that I do is I draw a rectangle. So I got a rectangular poster. It tells me that the area of that poster is 216 square inches. Do I know the length of my poster? No. So I'm going to call it L. Do I know anything about the width? So how could I write that? L minus 6 would be the right way. Length minus 6 would be the width. Now, what do I know? This is, the author kind of assumes this is common knowledge, which it really should be. What do I know about the area of a rectangle? Yeah. That would be volume of a box. We're not doing volume here. We're doing area. At least just length times width. Okay? So for us, we know that the area is 216. We don't know the length, but we called it L, right? And we know that the width is L minus 6. So we've got an equation now that maybe we could do a little bit of work with. So this is going to take using some of the things we did in lab today and the solving equation stuff that we've done in lecture so far. Okay. So on the right-hand side, what can I do with that L parentheses L minus 6? Yeah, distributed property. That's definitely what needs to happen right there. That's going to get me L squared minus 6L. So now it starts looking more like what we just did in section 1.4, because now I've got a quadratic thing going there. I've got an L squared and I've got a plane L. So if I've got an L squared and a plane L, what do I need to get the equation equal to? 0. Got to do that first. So I'm going to move the 216. So how do I move that 216? Minus. So there's my 0 equals L squared minus 6L minus 216. Now here's where I have options. I can try to factor this, or I could do quadratic formula. This one will work with either. You could do either with this one. My favorite way is factoring. That's what I prefer. Mainly because it's faster. Right? So I'm going to try to do factoring. So I'm going to do X method here. What goes on the top of my X? Try again. Negative 216. That negative sign is going to be very important. And then on the bottom of the X, negative 6. Okay, so I'm looking for things that multiply to be 216 or negative 216 and add to be a negative 6. So that tells me that one of them is going to be a positive, one's going to be a negative. Okay, so 216, I know 2 goes into it, so I'm going to start there. 2 and negative 108. That's way off. Not gonna go. Okay, so I'm going to try something bigger that goes in 216. So I'm just going to make maybe an educated guess here. Maybe 6. Does 6 go into 216? Yeah. 6 and negative 36. That's a little closer, but it's negative 30 is what that adds to be. So that's not the right pair. Negative 18 and positive 12. Negative 18 times 12 is negative 216, and that does add to be negative 6. Very good. Okay. It's trial and error there. It's just trying to pick things that multiply to be 216. And it's just trying things out of that. It's more or less guess and check is really what you're doing there. And we're just using the educated guess because we know 216 is even. We also know that 216 is divisible by 3. So that gets us the 6, and then that could get us the 12, and so on. All right, so now, how can I factor that? Do I need to do the grouping here, or can I take the shortcut? Yeah, take the shortcut. Because there's a 1 in front of that L squared. So this is going to be L minus 18, L plus 12. Those are my two factors. And then I'm going to set those equal to 0. And get L by itself. So the length is 18, or the length is negative 12. Which one of those makes sense? The positive one. Can't be the negative 12 because length can't be negative, right? So our length is 18 inches. What would our width be? 6 less than that. 12. It happens to be that other number over there, but positive. 6 less than the length. Remember, it told us that in the problem. So a nice little area problem with a rectangle out of that. That's kind of fun. But again, using some of the same skills, application of this. Now, are you going to do this at the grocery store? Probably never. I don't think Food Giant will ever ask you to do this, or Walmart or anybody. But it's just an application of what we're doing. It gives you some sort of use for that. Now, let's look at the next one, and let's get a triangle involved. piece of property is in the shape of a right triangle. The longer leg is 20 yards longer than the shorter leg. The hypotenuse, let's spell that right, is 10 yards longer than the long leg. Find the length of all three sides. Whew. So a good little word problem here. But it uses a right triangle. Okay, so we got to think a little bit about what we know about right triangles and some pieces of information. So first thing I'm going to do is I'm just going to draw myself something that looks similar to a right triangle. I'm going to put a right angle there, and I'm going to make it a little bit more obvious that we have a shorter leg and a long leg there. So I have a long leg, a short leg, and a hypotenuse. So which one of those is the hypotenuse? The slanted one, the one that's across from the 90-degree angle out of there. So that just reminding you about, that's our hypotenuse. Okay, so it tells us that the longer leg is 20 yards longer than the shorter leg. So do we know the length of the short leg? No. I'm going to call it X. The longer leg, so the straight up and down one there, is 20 yards longer than that. Not 20 times longer, 20 yards longer. Yeah, X plus 20. Now here's the tricky part on this one. What do I put for the length of the hypotenuse? If it's 10 yards longer than the long leg. Yeah, very good. X plus 30. Okay. This is a fun one. You can tell I'm a little bit excited about it because it's a lot of fun. Now, what do we know about right triangles? Got a 90-degree angle in them. That's true. Very much true. What else do we know works with right triangles? Named after a guy. Yeah, Pythagorean theorem. Remember Pythagorean theorem from elementary school? So Pythagorean theorem says that if you square, the sum of the squares of the legs is equal to the square of the hypotenuse. So remember, a squared plus b squared equals c squared. That's the Pythagorean theorem. We've done that before. It's been a minute. So what I'm going to call is the short leg A, the long leg B, and the hypotenuse C. So in our case, it's going to be x squared plus x plus 20 squared equals x plus 30 squared. So this is a lot of fun here. Okay, so this is using some of the things that we did in lab 14 tonight. So we're squaring that x plus 20 and we're squaring that x plus 30. So maybe writing that out there. I still have the x squared from the short leg. And then so I'm going to multiply those things out. So x times 30 is 30x, and then x times 30 again is another 30x. That's where the 60x comes from. 30 times 30 is the 900. Here, 20x and 20x is the 40x. 20 times 20 is the 400. So we've multiplied that out. And now I see that it's a quadratic because I got x squareds and plain x's in it. So I need to get it equal to what? 0. So let's work toward getting it equal to 0. Doesn't matter what direction you go here as far as which side you get it equal to 0 on. I'm going to put the 0 on the right-hand side. So I'm going to move this x squared by subtraction. Change colors with my pen here. Minus x squared. I'm just going to subtract it from that one. I'm going to subtract the 60x. And I'm going to subtract 900. That's going to give me a 0 over there because I moved all of that. So this x squared cancels out that x squared. And I've got x squared minus 20x minus 500. Okay. Now I've got an option here of trying to do factoring, but 500 is a pretty big number. And trying to find something that multiplies to be 500, negative 500, and adds to be negative 20 could be a little bit daunting. So I'm just going to go ahead and do quadratic formula because I know it's going to work. Doesn't matter if it does factor, quadratic formula will get me an answer. So that's what I'm going to do. Negative b plus or minus b squared minus 4 times a times c divided by 2 times a. That's 400 plus 4 times 500 would be 2,000. Is that right? Yeah. And then over 2. So I have 20 plus or minus the square root of 2,400 over 2. So I'm going to break down 2,400. That's 24 and 100. That's easy to do. And then that's 8 and 3, 4 and 2, 2 and 2. This is going to be 10 and 10, 5 and 2, 5 and 2. So I've got a lot of stuff in there. So I've got a pair of 2s here. I got a pair of 5s here. I got another pair of 2s there. Then I have a 3 and a 2 left over. So I have 20 plus or minus 2 times 2 times 5, radical 6. So 2 times 2 times 5 would be 20. So I have 20 over 2 plus or minus 20 radical 6 over 2, which is those are numbers. Okay, they're just a decimal number. We're going to simplify that. That's going to be 10 plus or minus 10 radical 6. Let's turn it into a decimal. I think that will make us feel a little bit more comfortable maybe. So I'm just going to do 10 plus 10 square root of 6 on the calculator. 10 plus 10 square root of 6. Yeah, let's round to one decimal place will be fine. 34.5 yards. What's this one? a negative, right? Can a length be negative? You ever found a tape measure that had negative numbers on it? They don't make those. They don't sell them at Lowe's, hardware store. Dollar General doesn't even have negative numbers on their there. So I know that the short leg is 34.5 yards. The long leg is 20 yards more than that. So that'd be 54.5 yards. And then the hypotenuse is 10 more than that. And there I found the dimensions. That was a little bit, probably a little bit more intense than the other one was, but doable out of that. All right, so a little bit of Pythagorean theorem mixed in there. All right, one more application problem, and then we'll get the inequalities and get out of here. So, all right, example C. A much shorter word problem. Find two consecutive integers whose product is 240. Two consecutive integers whose product is 240. Now, you could guess and check on this and figure out the answer, but I want to show you how to do it with an equation, okay? So the way that you would do this with an equation is you would need to establish that the first integer is x. The second integer would be the next consecutive integer, which would be x plus 1. That's what it means to be consecutive. So like if the first one was a 7, the second one would be 8, right? Because that's consecutive. If the first one was 22, the second one would be 23. That's consecutive integer, okay? So consecutive integer, x and x plus 1. If they said consecutive odd integers, it'd be x and x plus 2. Because odd ones, consecutive odd ones, they skip 1. You'd have to have the x plus 2, okay? So what's a product in math? Multiplication problem, right? So if I'm multiplying the two integers, their product should be 240. So I have x times x plus 1 is equal to 240. That's the product of two consecutive integers. Two consecutive integers multiplied together to be 240. Distributive property. Get it equal to 0. And then either factor it or quadratic formula. I'm going to do quadratic formula. So that'd be 1 plus 4 times 240 be 800 plus 160 be 960. Yeah, and then so negative 1 plus or minus the square root of 961. Now, work that out. Negative 1 plus the square root of 961 divided by 2. Negative 1 minus the square root of 961 divided by 2. Now, I'm going to go to my calculator and I'm going to get a little help with that square root of 961. Okay? I'm just going to second square root 961. Happens to be 31. I didn't know that. That's good news. So I really have negative 1 plus 31 over 2, which is 30 over 2, which is 15. I also have negative 1 minus 31 over 2, which is negative 32 over 2, which is negative 16. I got two different answers. If x equals 15, what's the second one? The next consecutive integer would be x plus 1, which would be 16. What's 15 times 16? That's the right pair. On the other one, if x is equal to negative 16, then the next consecutive integer is x plus 1. So negative 16 plus 1 is negative 15. What's negative 16 times negative 15? It's also 240. There's two sets of answers on that. One with the positive side of the, because it's integers, positive side 15 and 16, the negative side negative 16, negative 15 out of that. So the application problem, a little bit tougher, but the solving part, setting up the equation is the key, and the solving part's the same as that is, okay? All right. Last section of the night is 1-7. This is the last section that's on your next test, which will be next week. Remember, exam 3 will be next week. I will send a review out on the announcement this week that has everything that'll be on the test. And then you'll have the quizzes, and then we'll have labs and a little short review before the test next week. It'll be in person. But 1-7 is quadratic inequalities. So when you're solving quadratic inequalities, it's a process, okay? The first process, the first step, get a 0 on one side. Well, we've heard that already, right? That's what we did when we solved equations. We got it equal to 0, okay? Step 2, solve like it is an equation. So factoring, square roots, quadratic formula, any of those methods for solving that, okay? Step 3, set up a number line. With the answers on it. That's going to create test zones. Pick numbers in each test zone to test the inequality. True zones are the solutions. Okay, this kind of seems abstract at this point right here, but we're going to take this 5-step approach and we're going to work our way through a few problems here. Okay, so the first 2 steps are exactly what we've been doing. Get it equal to 0, solve it. just like what we've been doing all night. Get it equal to 0 and solve it. So let's start with example A. We'll start with something fairly easy here. X squared minus x is less than 12. Okay. So first step, get a 0 on one side. Okay, so I'm going to move that 12 over. So step 1, get it a 0 on one side, get it equal to 0. So subtract 12. So that's going to be x squared minus x minus 12. And here's where I'm going to write it as an inequality. Step 2 said solve it like it's an equation. So this was all step 1. Step 2 says do this. Just make it an equation and solve it. Okay? We'll come back to the inequality in a second. So we're just going to solve it. Step 2 was make it an equation, solve it. So I'm going to try factoring because I hope that works. Let's see if it does. Multiply to be negative 12 and add to be negative 1. Jonas.
We just went from an inequality to an equal sign.
Yes. Yes. That is the process we want to go through. We'll come back to the inequality in a minute. We've got to find, what we're trying to do is find where that inequality hits the 0. Because we're looking for where it's less than 0 according to the inequality. If we can find where it hits 0, then that's going to give us some regions that we can check in to there. So finding the where it hits 0 is going to be a key to finding where it's less than 0. So what multiplies to be negative 12 and adds to be negative 1? Negative 4, positive 3. So I can take my shortcut on my factors. I got x minus 4 and x plus 3 equal to 0. And I'm going to solve those, set those equal to 0. X minus 4 equals 0. X plus 3 equals 0. That's what we had done earlier. That's x equals 4 minus 3. That's x equals negative 3. So those are my solutions that I found when I solved the equation. Okay. Now, up there in my little 5-step process, it says, this is where we're going back to the inequality. It says set up a number line with those answers on it. Okay. So I'm going to draw a number line. So this is part 3. It doesn't have to be a really long number line, and it doesn't have to have a ton of numbers on it. It just needs to have these answers on there. Negative 3 goes here. Positive 4 goes there. I know because my inequality does not have an equal to mark on it that those two are going to be open circles on them. So they're negative 3 and positive 4 are not solutions to this inequality because that would be equal to 0 if negative 3 and 4 were answers. The inequality didn't have an equal to mark. It was just a less than. Okay? What that does is it creates 3 separate test zones, is what I call them. Okay? We got a test zone right here that's to the left of negative 3. So I'm going to pick me a number that's less than negative 3. It's to the left of negative 3. I'm going to pick negative 4. That's the closest one. That's a really easy one to do. So I'm going to pick a test point. So this is step 4 in that process. Pick numbers in each test zone to test the inequality. So this number is negative 4. I'm going to plug that into the inequality. So negative 4 squared minus negative 4 minus 12 is less than 0. I'm going to check that and decide if it's true or false in that zone. So this is 16 plus 4 minus 12. So that's 20 minus 12. That is 8 is less than 0. Is 8 less than 0? No. So this area is false. So that test zone is not where the answers are. Okay. Then I'm going to go to the next test zone between the -3 and the +4. What would be an easy number to plug in that's between -3 and +4? 1 would be easy. What would be even easier? 0. So I'm going to pick 0. And I'm checking it in my inequality. 0 squared minus 0 minus 12. That's going to be -12 is less than 0. Is -12 less than 0? Yes. So this area is true. Then I'm going to check the next zone. I'm going to pick me a number that's bigger than 4. 5. That's a good one. 5 squared minus 5 minus 12. Is that less than 0? So that's 20 minus 12. Ooh, that is not going to be less than 0. That area is also false. So this is kind of step 3 and 4 together. We got our answers, we put them on a number line, and then we started checking the zones. Picking a number that's in the zone and plugging it in, seeing if it's true or false. The true zone is the answers. Okay? So the answers are all the numbers that are between -3 and 4. So when we checked this 0, that showed me that any number that's in between -3 and 4 would work in the inequality. Okay? So my solution set. So part 5 is write the answers. The solution set. All x's, as long as x is between 3 and 4. That's the set notation. The interval notation for that would be parentheses -3 to 4 parentheses. So this is set. This is interval. I do both of those because I do not know which way they will put it on the final. They've done it both ways in past years. They tend to lean more toward interval, especially in Math 110, but in 100, they kind of bounce back and forth with all of it. So I try to do both in everything that we do so that you've seen it all, okay? A little bit weird. I agree with you, Jonas. It's weird dropping the inequality and go to an equation. That seems like the craziest thing in the world to do, but that sets up the pieces that we need there. That's what we're looking for. Okay, let's look at another one. See if we can do it. Example B. Let's say we had 2x squared minus 12 is greater than or equal to -5x. So a little bit different looking problem here. It has an equal to mark. It has a greater than symbol on it. So first thing is what? Get a 0 on that side. So I'm going to move that 5x over there. We'll add 5x. And I'm going to put it in order. Remember, we want it in descending order. So that 2x squared plus 5x minus 12 is greater than or equal to 0. Okay. So that's our inequality that we're going to test in, is that inequality right there. I'm going to solve it like it's an equation so I can get my numbers for my number line. So I'm solving 2x squared plus 5x minus 12 equals 0. Now, it's your option about how you solve that. If you want to do quadratic formula, great, do it. If you want to use factoring, this one will actually factor as well. I think I'm going to do factoring. What goes on the top of my x? -24. Good. And then 5 goes on the bottom. So we need numbers that multiply to be -24 and add to be +5. 8 and -3. We've seen that in a few times tonight, haven't we? Now, because it has the 2 in front of the x squared, I can't go straight to my factors. I got to do that grouping stuff. So this is a little bit longer to factor it, but it's still shorter to factor it than it is to do quadratic formula. I'm going to put the 8x in front, the minus 3x minus 12 in the back, and I'm going to group. So what do I factor out of the first group? 2x, and that's going to leave me an x plus 4. And then what do I factor out of the second group? Negative 3, and that leaves me an x plus 4. So my factors are 2x minus 3 and x plus 4, no matter which way you wrote those, what order. I normally write the x plus 4 first, but I don't know why I wrote it backwards that time. That's quite okay. It works either way. So we got our factors. Now we can get our solutions. 2x minus 3 equals 0. It's going to be x equals 3 over 2. And x plus 4 equals 0. That's going to give us x equals negative 4. And that's where I go to my number line. And if it makes you feel better to make 3 over 2 into 1.5, do it. It's fine. Nothing wrong with it. If you want to make that a decimal, if that makes you feel better, makes it easier for you to figure out a number. Okay? Now, here's the difference on this one. We've got equal to mark on our inequality. So those spots are going to have closed circles on them, because we had an equal to mark on our inequality. So now we're going back to the inequality, and now we're doing the test zones. We got 3 test zones for this. So we're picking a number to the left of negative 4. I'd go negative 5. I'd go 0, and I'd go 2. That would be my 3 numbers that I'm testing. And I'm going to put those into that inequality right there. That's the inequality that I'm using. Is that one right there. So I'm plugging in the negative 5. So I have 2 times negative 5 squared plus 5 times negative 5 minus 12. And I want to know, is that greater than or equal to 0? So that's going to be 50 minus 25 minus 12. Yeah, that is a positive, isn't it? Yeah, so that's true. That's greater than 0. So 50 minus 25 is 25. 25 minus 12 is 13. So that's true. So that little part is true. And then the middle part, I'm going to plug in 0. That one's easier to plug in. So I have 2 times 0 squared plus 5 times 0 minus 12. So that's negative 12 is greater than or equal to 0. So this area is false. The middle part is false. Now, it's possible that this little tail over here is false as well, so I got to check it. So I'm going to plug in 2 times 2 squared plus 5 times 2 minus 12. Is that greater than or equal to 0? So this is going to be 4 plus 10 is 14. Yeah, just a little bit more than that. So that's true as well. Okay. So here, writing the solutions is a little bit more. This one has got 2 different little pieces there. Okay. So you got this area here going that way, and you got this area here going that way. Those are your answers. Okay. So my solutions, this left one is all x values that are what to negative 4? Or equal to, yeah, less than or equal to. And then this one on the right is all the x values that are what to 3 over 2? X's are greater than or equal to 3 over 2. That's the set notation. The interval notation for that, you would have parentheses, negative infinity, up to negative 4 with a bracket, union, bracket, 3 over 2 to infinity. We've been working hard to get in between set and the interval notation. That's the key. Got to be able to do both of those things. You could, but your inequality that's excluding is going to be excluding everything that's between 4 and 3 over 2. So it's still going to have two endpoints on it. So your solution, you'd rather say what is the answer than what is not the answer. Because, I mean, if you're looking for a problem, you're looking for the answer, not the what's not the answer part. So, yes, it could be written as what's not the answer, but we want to write what is the answer. So, and it wouldn't be, I don't think it would be any, it's not really going to be any shorter to write what's not the answer on one like this. But that 5-step process is that on this every time on the inequalities. Okay. But the solving of the equation, that's the thing. You got to be able to do that, or you never get to this. Okay. So getting it equal to 0 and either solving by quadratic formula or by factoring, both are definitely valid ways of solving those. A lot of these are going to factor. You're going to find that they like factoring a lot in Math 100 because it's a skill you need. So they like to make you practice it. So a lot of it factors. Quadratic formula is important for when it doesn't, but most of them do factor. Okay. All right. So practice problems, if you want to look at some in the textbook, I'll write some up here, no matter which version of that textbook you have. And then 1.5, we did some stuff in there, some application problems. 1.7, 350. There's not as many problems in 1.7 as there are the others. Okay, so those are some practice problems if you want to look at those. You will have quizzes over these 3 on Canvas this week. And then I'll also send you the review for the exam 3, which will be next week in person, be on paper. And then also we'll do 2 labs next week as well, and then we'll have a little short time of review to get questions over the review before we take the test. Okay, so I'll see you guys next week. I appreciate you hanging with me. Be careful on the way home. Roads are still a little bit wet.